Welcome to the channel. In today's video, I am excited to show you a project I have been working on, a real-time collaborative code editor. This tool allows multiple users to code together in real time and execute script in various programming languages. I will be taking you on through a live demo, followed by a breakdown of system architecture and explanation of the tech stack used. So let's get started. Imagine you are working on a project with a friend or colleague and need to collaborate on code. With this editor, you can share a private code space using a 6-digit code and edit together in real time. This editor also supports running code in different languages, provide a seamless development experience without any setup hassle. Let's take a look at how it works. I will start by creating a new code space by entering my name as a Kishan. Whenever I click on create new room, it will create private code space for me and it will generate one unique 6-digit code which I can share with other users to join. By clicking on OK, it will redirect me to the code editor where user can enter their code. Here user can see how many users is connected. Here is the invitation code. Here user can enter their input, can select any language and user can see the output. Now let's say a few users join this code space. By sharing the invitation link or invitation code, you can let your friend join this private code space. Just copy your invitation link, share with your friend. Whenever your friend opens this private code space link, it will automatically add this 6-digit room code on the user side by entering the name. Hardik. Whenever users can click on join room, it will let Hardik to join this private code space. As you can see over here, Hardik is connected in this private code space. Same for other friend. Next, I am going to run a simple Python script by selecting a Python as a language and write a simple hello world program. By clicking on submit code, it will generate output in the output section of the each user which is connected in the private code space. As you can see over here, output section is written with the hello world program where you can clear output section by clicking on the clear button. Now let's check what happens when you misspell the print. Just remove T. By clicking on submit code, it will throw one error in the output section that hey, this is a name error where print is not defined. This is for the error handling. Now let's check how it handles the input. I have written the C++ code which take two integer and return the sum of that integer and the output section. Here is the code which take num1 and num2 as the input and return the num1 plus num2 in the output section. You have to pass input by 5 and 8. By clicking on the submit code, it will return the sum of the given input two integers. As you can see over here 13, also over here 13. This code execution is handled by the Docker containers, allow us to run code safely and efficiently in isolated environment. Now let's see what's happened when one user got disconnected. For example, if this user got disconnected, it will update user list and let other users that hey, yes, got disconnected. So this is the overview of the real-time collaborative code editor. Now let's deep dive into the system design. In system design, there will be main two parts. One is a collaborative feature and the another is code execution feature. First, we deep dive into how users collaborate with each other. So this system allows multiple users to edit code together in real time. Imagine a scenario where you and your friend are working on coding problem together and every changes one of you make it instantly reflected on other screen. That exactly what this system achieves. On the front end, I have used React for the user interface and Recall for state management. Whenever a user make an update in the code editor, that update is immediately sent to the backend through a WebSocket connection. The key element here is the room ID. Each private code space is associated with unique room ID and users sharing the same room ID can collaborate in real time. On the backend, I have implemented a native WebSocket server. When a new users join a room, they are subscribed to the room ID. The server listens for any update sent by users, and when it receives an update, it broadcasts the message to all users in the same room, ensuring that everyone see the changes instantly. So this is a synchronization across multiple users. For the output, I have integrated Redis Pub sub. The WebSocket server subscribe to the Redis channel using the room ID as the channel name. Any updates on the output section from the backend workers are published to the corresponding Redis channel. The WebSocket server listen to this channel and broadcast the output to all corresponding connected clients. Now you have questioned that why you choose this architecture. Because it offers low latency communication and ensuring real-time updates. By using the PubSub, it allows multiple users which is connected in the private code space to share output at the same time. To recap this part, a user connect to a WebSocket server, join a room, and any updates they make are broadcasted to all other users in the room through a WebSocket server. Now let's move on to the second part of the system, the code execution feature. This part is all about running user submitted code securely and returning the result in the real time. On the front end, when a user is ready to run their code, they click on submit code button. They send a post request to an Express backend with detail like room ID, input, code, user ID and language. The request hit an endpoint named as submit. On the backend, the Express server receives the request and place it into the Redis queue. This Redis queue helps manage incoming requests. Next, you can see over here that I have set up a cluster of worker nodes to handle the code execution. Each worker node listens to the Redis queue, pick up a task and filter them based on the programming language. The actual code execution happens inside the Docker containers, which provide an isolated environment to run the user code securely. Once this Docker container completes the code execution, it returns the output to the worker node, and the worker node then publishes output to a Redis channel. Using the room ID as a channel name, the WebSocket server already subscribed to this channel receives the output and broadcasts it to all users in the room. This way, everyone sees the result of the code execution real time. I choose this design because it offers several advantages, like the Docker containers provide isolated execution, minimizing the risk of malicious activity on the host system, and using the cluster of worker nodes with the Redis queue management allows for efficient vertical scaling, handle more tasks concurrently. By integrating Redis PubSub with WebSocket server, users receive immediate feedback, enhancing the real-time experience. To sum it up, the frontend sends the code to the backend queues the request, a worker node processes it using a Docker, and the result is broadcasted back to the users in the real time. In conclusion, this project brings together a collaborative WebSocket system for real-time code editing and secure code execution feature using a Docker containers. By using these technologies like native WebSocket, Redis PubSub, and Docker, I have designed a system that is both efficient and scalable. If you found this breakdown helpful, please leave a comment and let me know what features or improvements you did like to see next. And don't forget to like and subscribe. See ya.